All right, Unit 4 review. Let's take a look at some of these problems here. So, all about quadratics here. So the first question here, identify the vertex and the axis of symmetry of the graph of the function. What's so awesome about this particular quadratic is, as you guys know, this one is in vertex form. What vertex form? You have your a x minus h squared plus k, which means that the vertex is located at HK. You've heard me say very frequently during class, this is an opposite same game here. So the numbers that we should be paying attention to on this equation, the only thing that really matters when it comes to the vertex is going to be this number right here. And that number right there, there's your H and then there's your K. So now I can say the vertex of this graph should be at positive 3 and positive 2. Because the vertex of the graph is at positive 3, positive 2, the axis of symmetry should be cutting right through the vertex at the x coordinate spot. So the axis of symmetry, what we're looking for, is the line x equals 3. Let me show you another way you could have done this. We could have just typed it into our graphing calculator, just like this, negative 2, x plus 3 squared plus 2. Then hit graph. Hitting graph is important because then it gives you an idea of where the vertex should be approximately, whether it's a positive x value or a negative x value. Sometimes you might be able to tell right away where it's at, but to seal the deal, go to the table of values by pressing the second button and then hitting graph. We know the vertex has to be a negative value for x, so let's look at those negative values for x, and then something should pop out at us right here, and that is right here at negative 3 and 2. You see some symmetry going on here with those y values. So this is another way you can state where that vertex is. Go to the graphing calculator, approximate where that vertex should be, go search for it in your graphing calculator. The y column there should give you some pretty good clues because of the symmetric nature of the ordered pairs. And so we have a vertex right here at negative 3 and 2. Likewise, that axis of symmetry line, there you have a line that's going to cut right through. If I can do that right here, I will. Sure, I can do that. There's a line, cuts right through there, right? Not very straight, but I think it does the job. Cuts right through there, and I think that looks to be like that's negative 3. Hey, maybe I should check my answer. Did I write the correct answer here? Yep, 3. Cuts right through there, right there with 3. Okay? So there's two ways of doing that one. Take a look at this question. Question number 2. Use the vertex form to write the equation for the parabola. So if I want to write this in vertex form, remember that guy right up there, a times x minus h squared plus k. That's vertex form. So key thing of vertex form, how about we find that vertex? So that vertex, pretty easy to spot right here. Let's write the ordered pair for that one. Looks to me like we're at 2, comma 2. So if we're trying to write this out here, here's what I know so far. X minus h squared plus k. Because the vertex, there's h and there's k. So far, so good. I have x opposite, so minus 2 squared. Same, since it's a positive 2, we're going to do plus k. What we still have yet to address here is we still need to talk about that a value. A couple things that we know about a. Number 1, a is the width of the parabola. In other words, the higher a is, the skinnier the parabola will get. Here's one thing I want you to notice about these ordered pairs. About the graph. There's ordered pairs. There's one right where the vertex is, and then you got 2 more right here. In other words, we went 1 to the right, and we went down 2 units. The parent function of a parabola, which would be right here at 0, 0, would have went only 1 to the left and 1 to the right and up 1, just like it would go 2 and then 4 and 4 there. But you notice we're not actually doing that here on this one. So here's the cool thing about this, and maybe I should have said this to start off with here. The cool thing about that is if you go 1 to the left or 1 to the right, that vertical change is actually telling you what a should be. So if that vertical change were here, and now we're here and we went down 2, guess what, ladies and gentlemen? A has to be negative 2. And then you can fill in the rest with the exact same stuff that you just did there with the vertex. So there's your equation right there in vertex form. If the parabola was opening up and we still saw those same dots, say up going up 2 after we go to the right one, then you're right, that would be a positive 2.